It starts, there it goes. All right, so section 3.1, new chapter, brand new start, okay? Forget everything that's behind you, look ahead. Don't forget everything's behind you because you're going to have to know a lot of that stuff to do what we're going to do, but you get the idea. Okay, if you haven't done well and if you underperformed, okay, let's put that behind us and let's do a little bit better, okay? It's a nice thing about going to a new chapter, always gives us another chance to do better. All right, so here it's called symmetry and coordinate graphs. Okay, you know what coordinates are, right? We're going to do a lot of graphing, all right? In the next couple chapters, we're going to do a ton of graphing. So just going to have to get used to it, okay? You're going to have to know what's going on. Let's talk about that word symmetry. Symmetry basically is kind of like looking in a mirror and seeing the same thing next to it, okay? Or a lot of times if you put, like if I had something like this and if I put a mirror right in the middle of it, you can see the same thing on one side as the other side. If something is symmetric, it's basically the same thing on one side as it is on the other side, okay? That's kind of what we talk about when we talk about symmetry, something being symmetric. They start off with a line. We'll just do what they do. And put a point right here, okay? Call it whatever. They call it point N. All right, so look, everything going this way, if I completely like flipped it, all right, if I put a mirror, right, if I put a mirror right here, okay, what would it look like over here? It would look just like this, wouldn't it? All right, so if I, watch this, if I, oops, just put it right there. Oops, don't want to do that. Oh, that's good, actually. That's good. Okay, watch. If I put a mirror right here, then what would it look like on the other side of the mirror? Same thing, just going in the opposite direction, okay? It's kind of ugly, but you get the idea. You with me on that? So think about that mirror, okay? That's pretty important, okay, because that's what we're going to talk about in a few minutes. So let's take another graph. Now, this graph, I'm not expecting you to be able to graph it today. Another day we will. Tell you what, I'm using a graph a lot today, so let's just grab this and copy it. Okay, if I had a graph like this. Now again, yeah, this thing's been buzzing out on me, that projector. I don't know why. I'm not even doing anything. Like, there it goes again. So let me just wiggle it a little bit. I don't know. There's like a short or something, or I don't know if it's short or what it is. But anyway, it's acting weird. It's the connection. It's not the projector itself. Yeah, it is buzzing. It's been buzzing all year. But anyway, there's something here. Because if I just like barely step on that cord, it'll go out. So it's not the projector itself. It's the connection. I must have to get another cord. So let's do this. Let's draw a graph. Don't get freaked out by this graph. All right? Because right now, you're not really going to have to graph it, okay? We're just looking at the graph and we're going to just see what's true about it. So watch. If I took this and put an arrow here and an arrow here, and let's do this. Let's copy it. I was practicing this a little earlier. Let's see if I can do it. All right, so if I copied that thing right there, and I think if I go to transform, actually what I want to do is copy and paste it. Did it paste? No. Let's try this again. Copy, paste. There we go. That's what I want. All right, and I take this thing and I just flip it horizontally. There we go. That's what I want. And I put it right there. Everybody see that? Same exact graph. Copied and pasted it. But I flipped it, didn't I? Where's the mirror here? If you think about the mirror, in the middle. It's right in the middle. It's that y-axis, isn't it? Okay, it's at the y-axis. All right, so we say that these things are symmetrical. All right, they give a fancy definition for it. Let me just read it. I'm not going to have you write it down, but it says a figure is symmetric. Now, here's the thing we're going to say a lot today. With respect to, all right, we're going to use that all the time, a lot today. So with respect to a given point, it can be rotated 180 degrees about that point and appear unchanged. All right, so what did I do? I took a point right here, or all these points right here, and I flipped it 180 degrees. Everybody see that? So watch, look at my hand. It's like this, and I just went boop, like that. So they appear the same, it's just flipped on the other side. Everybody with me on that? So that's symmetric, that's symmetry. All right, so we are going to talk about with respect to something a lot today. So let's start with the first one. So let's talk about symmetry. Oops, let's go to white. It's easier to read, I think. So symmetry with respect to, I'll just put W/ as my with respect to the origin. Now, we're going to do with respect to a lot of things today, all right? But the first one we're going to do is with respect to the origin, all right? And what in the world does that mean? Well, I'm glad you asked. Oops. Let's grab this graph. Okay, and what I'm going to do is I'm going to graph like something that's fairly easy to graph, but let's just write out what the equation is, and I'll show you. So f of x equals x cubed. We're going to graph that. Now, that may not be super familiar to you. I don't know, it might be. You probably did quite a bit of this in Algebra 2 with x cubed. You have any idea what that looks like? Well, let's do a little table. All right, I'm going to go x, and then I'm going to, let's put some points in here. Let's just go -3, -2, -1, 0, 1, 2, and 3. All right, this is always a surefire way to be able to graph something. Just do your table. It's like going back to pre-algebra when you first did your very first graph, maybe Algebra 1, where you set up a table and then you figured out what was here. What we're going to do, instead of calling this y, what are we going to call a second column? F of x. Good. All right, so we're going to call it f of x. So what we're going to do, here's our formula, here's our equation, and I'm going to plug these numbers in. So if I put a -3 in for x, what do we get? You can do this in your head. -3 cubed. It's -27. Okay, put in a -2, -2 cubed, -8, keep going. -1, 0, and then what? 1, and then 8, and then 27. All right, so let's kind of see what this is going to look like. Now, obviously, I'm not going to go up to 27, but you're going to get the idea, I hope. So 0, 0 would be right here, right? 1, 1 would be right here. So does that mean it's just a straight line like this, like we did in Algebra 1? No, it's not just going to be a straight line, because what happens? There's 1, 1, 1. What if I go to 2 right here? Where am I going up to? I'm going way up here to 8. You see that? Then if I go to 3, where am I going? I'm going way up here. Is this a straight line? No. So it goes like that. Okay. What about the negatives? Put a -3. What? Let's start here. 0, 0. Let's go -1. So it's -1 what? -1. Okay. -2 what? -8. You get the idea? And then your graph goes like this. Is that the first time you've graphed a x cubed graph? You didn't do this in Algebra 2? No. Seems like that's something you would do in Algebra 2. I don't know for a fact, but seems like it should be. Anyway, but now you know, okay? It's not too hard, is it? Understand what that looks like? All right, so that's that. So what we're going to do is we are going to see, is this symmetric? Now, let me grab that thing again. Let's just pull this out. Is it symmetric about the origin? Okay, now here is how we know if it's symmetric about the origin. So you might want to keep like a little, like a list of things. Maybe it's on another sheet in your notebook, or maybe you just put a line there and just list all these things that are with respect to. I think there's like 4 or 5 of them that we're going to do. All right, so symmetry with respect to the origin. That's the very first one. So what they do is they write this. If f of -x equals -f of x, then it's symmetric with respect to the origin. All right, so let's take a look at it. Where's the origins? Right here. Would you agree? So what did this thing do? Did it just flip like my hand? Did it just flip across like that? No, it flipped across and then it flipped what? Flipped down, didn't it? I can't do that with my hand, but you get the idea, okay? It flipped across, right, and then it flipped down like that. Would you agree? So it went like this, and then you flipped it down, and so half of it goes this way, half of it goes this way. All right, so it's kind of what we're talking about. So let's just do some things here. Let's make another column, and let's make a column. Oops, I ran out of room. There we go. Let's make a column with f of negative x. Now, what does that mean? That means instead of putting x in for x, what are we going to put in? Negative x. So instead of negative 3, we're going to put in a positive 3. Everybody see that? All right, so if we put that in there, what do we get? What if I put in a positive 3 in for this x? So this is the thing we're plugging stuff into, okay? Yeah, you'll get a positive 27. Agreed? And then if you put in a what? A negative 2, which is a positive 2, and you put it in there, what do you get? Positive 8. Do you see the pattern? Okay, let's keep going. What's this going to be? 1. This is going to be what? 0. Now let's think about this. This is going to be a negative 1, right? Because I'm putting what? The negative of x. X is 1 right here, so I put in a negative 1. What do I get for that? Negative 1. And then keep going. Negative 8, negative 27. You could keep going if you wanted to, but we'll stop right there. That's my f of negative x. In order for it to be symmetric with respect to the origin, the f of negative x has to be the same as negative f of x. All right, so let's make another column. Let's make this what? Negative f of x. So we already know what f of x is. We already filled that in. So what's negative f of x? Well, what would this be? Here's my f of x, which is negative 27. What's negative f of x? 27. What's the negative of this f of x? Positive 8, correct? What's the negative of this f of x? It's positive 1, and then 0, and then what? Right, the negative of this f of x would be negative 1. The negative of this f of x would be negative 8, and so on. Okay? So why'd we do that? The question they're going to ask you, is this equation or is this graph symmetric with respect to the origin? So we have a little test. What's our test to see if it's symmetric to the origin? It's this. If f of negative x is equal to negative f of x, then it's symmetric with respect to the origin. So let's look at our columns. Are these exactly the same? Yep, they're exactly the same. So f of negative x definitely is equal to what? Negative f of x. Okay? So is this symmetric to the origin? Yes, it is. All right? Now, how do we know that just by looking at the graph? Well, if you look at the graph, if I take it, right, and I flip it this way, and then I take it and I flip it this way. Let's see if I can do that. I don't know if I can or not. Haven't tried this yet, so let's give it a shot. I'm going to retrace this in yellow, but I'm only going to do half of it. Okay, so I've got that. Everybody see that? Then I think I can grab this and I can flip it horizontally. See that? But if I flipped it, it would be like that. Yes? And then I'm going to take that and flip it what? Vertically. But I got to slide it down. Everybody see that? So if I take the half of it, right, and I flip it horizontally, and then I flip it vertically, all right, keeping that same point. This program, I think there is a way I could have anchored it right here, but it just didn't do that. It just flipped it like right on top of itself. But if I took this and I flipped it over here and then I flipped it down here, then I've got that graph. Okay, that means it's symmetric about its what? Or with respect to. A lot of times we'll say about. I might say that a lot, but the book says with respect to. I might say it's symmetric about the origin. Okay, that's the way I think I was taught, I guess. For some reason that pops in my head. All right, so symmetric about the origin or symmetric with respect to the origin. That's what would go on right there. Does that make any sense? All right, so remember this. Put it in a place where you're going to remember it. Maybe keep a list of these things. Okay, your list would say symmetry with respect to the origin, and then right next to it or below it or wherever, you're going to write that. If this is true, then it is symmetric with respect to the origin. Okay? All right. I know it's weird. I get it. Let's do this. Let's copy this because I'm going to use this again. Let's do an actual example they give you in the book. So here's what they ask you to do. They ask you to determine whether each graph is symmetric with respect to the origin. Each graph, they give you two of them, all right? The first one they give you is this. F of x equals x to the fifth. Everybody see that? What I'm going to do, thank you. I just want us to visually see what that looks like. All right, x to the fifth. It's not a super common thing, but with the graphing programs that they have today, it's kind of easy just to graph it. So I'm going to go to the Desmos. Watch, I click off of that. There we go. And I'm going to go to this. And so I'm going to put in, well, I tell you what, let's just use this thing. I'm going to put in y equals x to the, I think, where's the to the power? Oh, there it is. To the fifth. There it is. That's what, and it kind of looks like the cubed one, doesn't it? Except it just goes a little bit flatter, then boom, it takes off like this. Does that look symmetric to the origin? Yeah, it looks very, very similar to the y cubed one. Would you agree? If I flip it this way, right? If I take that, flip it that way, and then take this, take it, and then flip it down here like this, yeah, absolutely. It definitely looks like it's symmetric to the origin. Would you agree? So sometimes it's nice to be able to just put it into a graphing program and see if it should be symmetric. Let's do the math and see if it's actually symmetric or not. All right, so I got to go back to this, unclick that. There we go. All right, so what we're going to do, what's our test? Our test is to take f of what? Negative x, and see if it's equal to what? Negative f of x. All right? Everybody with me? All right, so let's do this. Let's go f of negative x. So here's my x. What do I want to make it now? I want to make it negative x. So let's put in negative x in for x. But it's being taken to the what? To the fifth power. Agreed? Now that should equal, if it's symmetric about the origin, it should equal negative what? And what's f of x? It's x to the fifth. So this is what we're attempting to see. We want to see if this is true. All right? Is this equal to this? You understand what we did? I used this little test, all right, that they gave us. If this is true, right here, if f of negative x, what does that mean? I just put a negative x in for x, right? So here's my x. So what do I put in for that? I put in a negative x, right? Take it to the fifth, because that's what that function tells me to do, right? And it should equal just a negative out in front of our original function. Our original function is x to the fifth, right? And so all I did was just put a negative out in front. Does this equal this? Well, it's x to a odd exponent, right? So what is negative x to the fifth? So let's do it. What's negative x times negative x? Positive x. Times another negative x? Negative x. Times another negative x? Positive. Times another one, our fifth one, it's negative x. So what is negative x in parentheses to the fifth equal to? negative x to the fifth. Does that equal negative x to the fifth? Does it? Question mark. Of course it does. They're exactly the same thing. Would you agree? So, what can we say about this function? We can say that this is what? Symmetric to what? Or with respect to? Right. With respect to the origin. And that's the question they want you to figure out. Is it? Yes, it is. It is symmetric. It is. All right, we'll do that. So it is symmetric with respect to the origin. So part A, yes, it is. That's our answer, basically. All right? I know it's weird. All right? Is a little bit of this sinking in? All right, let's try another one. Part B. We're going to use g of x this time, just to make it different than the f of x. Different function. X over 1 minus x. Now, just for fun, let's put it into our computer program. And there we go. And let's just get rid of that. And let's put that in there, if I can. All right, so it's x over x divided by 1 minus x. Do I have to put parentheses? Probably. 1 minus x. Close parentheses. Boom, right there. All right, there it is. You see it up there? That's x over 1 minus x. That's what we want to see. Is it symmetric about the origin? Look at that. Does it flip across the origin, though? No, because the origin's here, right? If I just took it and flipped it, it's not symmetric about the origin. Now, it is symmetric, all right? But it's symmetric like right here. Like, where would the mirror be? That's a good question. Where would the mirror be? It would be like right here, wouldn't it? Be a straight line, diagonal line that goes through them like that, all right? But is it symmetric about the origin? Do I flip it across the 0, 0 point? No, all right? I can't just flip it across the 0, 0, and then they're going to be the same exact thing. So I can see visually that this probably is not symmetric about the origin. So let's go back and do the little test and see, all right, if it works. So here's our little test. We're going to go f of negative x, and we're going to see, does it equal negative f of x? So what are we going to do first? What are we going to put in for the x? What are we putting in for this x right here? What if it was f of 2? I don't think everybody's getting this, okay? What if it just said find f of 2? What would you do? Put a 2 in for that, and then put a what? A 2 in for that. But it's not f of 2. It's f of what? Negative x. So what am I putting in for that x? I'm putting in a negative x. Does that help? Okay. Lost a couple of you guys already. Not a good start. So what am I going to make this? I'm going to make this what? Negative x over what? 1 minus, again, what are we putting in for that x? A negative x. Everybody see that? Let's see what we get. We get negative x over what? 1 plus x. Now, let's see if that's the same exact thing as if I just took this and put a negative out in front of it. All right? That's what this is telling you, isn't it? It's saying take your original function, okay? It's really g of, because I made it g, okay? But it's g of x. But take my original function and just stick a negative out in front of it. So what's that going to look like? Watch, I'm going to put an equals and I'm going to put a question mark. So I'm not really sure right now if they're going to be equal to each other or not. All right, so let's put a negative x in for that. I'm sorry, put a negative out in front. Is that the same as this? Well, let's simplify it a little bit. What does this mean with negative out in front? It basically means you just multiply the top by -1, doesn't it? So let's do that. What do I get? Negative x. Over what? Whoops. 1 minus x. Does this, put a question mark, does this equal this? Is it the exact same thing? It's not, because this one comes out to a 1 plus x on the bottom. This one comes out to a 1 minus x on the bottom. Are they equal? No. So is it symmetric with respect to the origin? No, it's not. All right, so that's what I would say. No. All right. Whoops. Come on, pen, help me out. No. All right. It is what? Not what? Symmetric with respect to what? The origin, correct. To the origin. I know it's weird, okay? I get it. And I don't think I want to do any more than that today. Tomorrow, we're not just going to be talking about with symmetric about the origin. We're going to be talking about 4 other things. I'll just list them, all right? So 4 other, I don't know, line symmetries maybe, if you want to call it that. I didn't really write that down. Symmetries. What's a plural of symmetry? How do you spell symmetries? Like plural. Is it IES? Somebody look that up. See if that's right. Okay, 4 line symmetries. I didn't write that in there. So what we're going to do tomorrow is this. Is it IES? Okay. So we're going to find out that is a graph symmetric to the x-axis. We're going to find out if it's symmetric to the y-axis. We're going to find out if it's symmetric to the line, I'll put line, y equals x. And then we're going to find out, is it symmetric to the line y equals negative x? So now that we kind of have an introduction on what symmetry really is, there's little tests for all 4 of these as well, all right? It's not the same test as what we did up here, okay? The f of x equals negative f of x. All right, it's a little bit different, but that's the kind of stuff they're going to ask you. They're going to give you an equation, and they're going to ask you like 4 things. Is it, or maybe 5, is it symmetric to the origin? Is it symmetric to the x-axis, y-axis, the line y equals x, the line y equals negative x? And you have to show why it is symmetric or why it is not symmetric to those particular lines. You follow me on that? All right. So I'll tell you what, we got 5 minutes. Let's just do a sneak preview, okay? Let me see. There, got my graph right there. So check this out. What if I had a graph? Now, you don't really have to graph these. They give you the graph, okay? It looks kind of weird. You may have never graphed anything like this in your life. Like this. But we will eventually graph these things on our own, okay? And you'll know what they are. Let's check this out. Again, the mirror thing. Which one of these 4 do you think it's symmetric to? Like, where would you put the mirror to get the same thing on the top and same thing on the bottom? On the x-axis, that's exactly right. So this graph right here is symmetric to the what? To the x-axis, okay? Everybody with me on that? All right. So here's another graph. And these aren't the only graphs that are symmetric to the x-axis. It's just an example, all right? So what if we had a graph that looks like this? That's symmetric to the y-axis because it's the same on one side as it is on the other side. You follow me on that? Okay. So that's not too hard, right? If you can, that was symmetric to the y. Here's a crazy one. Watch this. And there's more to talk about tomorrow, but this is just sneak preview. Here's a crazy graph. You guys never saw this in Algebra 2, these graphs? No? Okay. That's fine. We'll get to them now. Now check this out. I'm going to put a little dotted line here. What's that dotted line, do you think? Yeah, it's the mirror, but what is the actual line? What's the equation of that line? It's right there on the screen. Y equals x, right. This graph right here, that dotted line is a straight line. It says y equals x. Look at the curvy graphs on there. Isn't that where you would put the mirror to get the one side looking like the other side? Absolutely. So what do you think this is? This is symmetric to the y, the line y equals x. Okay? Everybody with me on that? All right, let's get rid of those things right there. And then we got one more, and I think I'm going to draw my ellipse. I'm going to have to slant it a little bit, but watch. I'm going to draw an ellipse. It's an ellipse. And let's try. And we will be graphing stuff like this eventually. All right? Bet you can't wait, can you? That's pretty good right there. All right, look at this thing. All right, watch this. Yes? I'll send her in about 3 minutes. Is that all right?
Okay, thank you. Bye-bye.
All right, so what's that graph right there, that dotted line graph? Take a wild guess. It's y equals negative x. That's correct. All right? Everybody see that? Because look, if you go over positive 2, you go what? You go down 2, negative 2, right? If you go to the left, you go up. Do you see the negative right there? Yeah. And look at this. And I didn't draw this very accurately, but this kind of splits that ellipse in half, doesn't it? And it looks kind of the same on this side. If I did a mirror, right, it would look the same on this side as it would on this side of it. So this would be symmetric to the line y equals negative x. There's a little more to it, but at least we got you started, okay? So you kind of know what to expect tomorrow. Bet you can't wait, can you? All right. Yeah, I'm not going to give you any assignments tonight, okay? We still got a little bit more to do. So, but look it over. Watch a YouTube video on it, okay? Go to the title of the lesson. What's the title of the lesson? Symmetry and coordinate graphs. That's what I would do, all right? Man, I couldn't imagine if I was in high school or in college and I could just type up on my phone a topic and somebody's going to teach it to me. That would be incredible. So you guys live in an age where you don't even do it. But it's so useful. Why? Because it takes time. I get it. And it's kind of boring. I get that. But if you really want to learn it, that's how you do it. Go to YouTube. YouTube's your friend. Don't just watch stupid cat videos and grandma's falling over, and stuff like that. Whatever you watch on YouTube, all right? Go to stuff that you're going to learn something from, all right? Go to this, watch it, and you'll probably learn more than what you're going to learn listening to me. All right.